Okay, welcome back. Now we're going to do a little bit more. We've only got a few slides to do, and then I'll stop. Now this is a very formal way of looking at trigonometric values. Functions of any value is a lot different to, not really, the idea that we can look at exact values. So we can use our exact values experience to inform us about what happens here. So I think that's important. Okay. Now for our particular example, this is now something that I said in the lecture that was very similar to what we do. We kind of do this by recognition. This shouldn't be a big deal for us. This is another way of expressing these ideas that I've talked about. We've got an association, okay, x and y, sine and cos. We've got proportion, which is size, okay, and then we've got our plus and minus, our sign. So those three things are being expressed in an equivalent way when we look at these. That's the intention of this. And the intention of this is to do the same thing, just the way that we've been doing it, but our way is a bit more intuitive. This way is not so intuitive. Now these triangles as they've been presented don't jump out at you as being directly recognisable. But my question to you is, these are not any angle. These are the angles that we've been dealing with. So having said that we're doing an introduction to any angle, in actual fact what we're doing is we're looking at exact values trig. So if we think about our particular examples, we have an example where if we have a 45-degree angle, then both of the sides are the same. Okay, and the hypotenuse is 1. In our version, it's 1 over root 2. Okay, 1 over root 2. So in our version, this point here, this location as an ordered pair would be 1 over root 2. 1 over root 2. So it's just another way of looking at it. This angle here, theta, is still pi on 4 or 45 degrees. It's still the same. So what's the difference then between this one here and this one here? And it's simply proportion. Okay? It's proportion. If I multiply, and what's the multiplier that's given rise to 2 root 2? And why can they say 2 root 2? Because it's 45 degrees. So the giveaway is that it's a triangle. It's an equivalent triangle with a point A of root 2. Okay? But it's still 45 degrees because they're the same length. That means that's root 2 and that's root 2. Okay? Now what's the value of the hypotenuse? Well, the hypotenuse is just Pythagoras. So it's a multiplier of 2. Okay? It's a multiplier of 2. Now you can work that out. If you want to go to the length of working that out, r is equal to the square root of root 2 squared plus root 2 squared. You can do it, which is the square root of 2 plus 2 is 4, which is 2. So what's happened here is the proportions have been doubled. The angles are the same. So this is a good way to look at it, but the proportions are different. So what's happened is, what do we do if we get this and we multiply it by 2? Okay, if we multiply it by 2, so let's do that. Let's take our triangle. Let's do a bit of work on it. 45 degrees. Same length. So 45 degrees. Pi on 4. Now let's take our triangle and play with it. This is kind of the last step, isn't it? So we'll times it by 2. So everywhere we'll get a 2. So we'll get 2 times 1, 2 times this, 2 times this. The angles will stay the same. So now we get a slightly bigger triangle. Same sides. I haven't quite drawn that perfectly square, but so this is now 2 on root 2. 2 on root 2. Okay? Now what I want to do is I want to rationalise. Now that's the same. 45 degrees, pi and 4. Because they're the same size. Now I want to rationalise this. Let's have a look at this. 2 under root 2. We're going to times it by 1. So it's still root 2. Okay? The one that we're looking to multiply it by is root 2 over root 2. And look at this. Root 2 over root 2 squared. It's going to disappear, isn't it? 2 root 2. So what we're going to get here is 2 root 2 over 2. Wait a minute. They're going to cancel. It's root 2. Now, it's very unfamiliar because we haven't done that before. But this is actually the same thing. It's just a different size. Okay? And in this case here, it's a multiplier. So these thirds play around with your thinking, but essentially we're looking at the same diagrams. What about the minus 1 root 3? How's that working? So what we've got in our triangle is we've got our 60-degree triangle. Okay? We would normally have root 3 on 2 and minus a half with a 1. So what's happened now? Oh, it's been scaled. It's been multiplied by 2. So when we come and look at it, it's twice as big. Exaggerating? 2 root 3 minus 1. Oh, but the skill here is recognising the change in proportion. Okay, just because they've been moved around, that's okay, but it's just a change in proportion. They're actually the same thing. So we're not learning anything new with regard to exact values. Okay, I don't use this. I just don't have faith in it. I think you're much better off learning your exact values trig this way. Okay, of course, in different quadrants, we're going to get different results. But we know that because we, instead of using the all stations 2, we're using this one. Okay, and we're doing it by sight. And we're analysing the x and y values at every location. It's just a different method, but essentially it's the same thing. We need to learn how to do our proportion and association, regardless of which way we do it. Okay? So when we come to do our parts here, are we learning anything new, really? No, not really. Okay? What we're learning is that in different parts of the... so I'm going to put mine next to it. Okay? I'll put mine next to it because I like doing it this way. And then the same length. And then the big angle and the smaller angle. Bit of exag. Then the same length. Whoops. And then the little one. And don't forget, we're also looking on here and on here. That's not mentioned over there, but we're looking at those parts as well. Okay, so curriculum systems deal in things in different ways. So this is our diminishing triangles. And this is how all stations do. So I have a lot to do because I have to include it this way because some of you have learnt that. Some of you haven't, so that's good. You'll just go with this. But it's the same thing. So what's this mean? It means positive. Positive. Oh, okay. Oh, so what have we got? Association. Proportion. Plus minus. Okay. So we've got positive y's, positive x's, positive y's. There you go. Well, so what's this one saying? Sine's positive. There it is. Sine's positive. What about cos? It's negative. Look. There it is. Cos is negative. Cos is negative. Cos is negative. Even down to -1. Okay, -1. It's negative cos. Okay, think about it in terms of cos, y, and x. But we want to maintain the angles, so we've kind of got this duplicity about the angles. Okay, because I know them, don't I? I say pi on 2. But we're also superimposing y and x. A bit cheeky, isn't it? It's just a way of counting the angles. Okay, what about this one down here? Sine's negative, cos, yeah, obviously. Look, sine's going negative too. Cos is already negative. What about down here? Sine only is negative. Cos has become positive. Oh, there it is. Cos is positive, sine's negative. So that's all. We're not learning anything new. Okay? All we're doing is learning to recognise where the x and y's are positive. And this is the bit that this doesn't do. It doesn't do the association very well at all. Okay? Where are your x and y's positive? Where are they negative? That's the thing that we want. Okay? Now, this one here, sine theta is negative. Tan theta is negative. Now, to get a negative tan, it's got to be a plus or a minus. So either sine's positive and cos is negative, or the other way around. Cos is negative and sine, because remember they're a quotient. Tan's a quotient. Okay, so you've got to have that. So where is sine negative in these quadrants? But why would we need to know that? It doesn't really help you. This is a ridiculous question, in my view. It certainly doesn't help you in Maths 1. But anyway, let's hear it. Sine's negative in both these two quadrants. So let's call them the quadrants. 1, 2, 3. It's just silly. Silly. But we can do it. 3. So there's sine. Sine's negative in both of these quadrants. But what at end? Tan theta. So sine's negative. So sine's negative in these. That's this one, isn't it? If cos is negative. Hang on, that's negative. Cos has got to be positive. Sine's got to be negative. Right. So we've already got this one. So where is cos positive? So it's only quadrant 4. Okay. So it's only in quadrant 4 that's true. Okay. So it's more important, I think, that we get to develop our sense of those. All right, where it can come into help, okay, is that if we think about these kinds of things. All right, so in this particular one, we're looking to see our values, okay, and our values represent can be made up values, okay. Now, sine 120, this is self-evident. Because if we draw our exact values triangles, sine 60 is that one, sine 120 is that one, and what's sine? Y. Oh my goodness, it's √3 on 2. Okay, you can't get that from the other way. That's it. That's all we need to know. Okay, that's all we need to know. This is really about repeating. So in tan 200 is 180, or pi, which is 180. And this is the other thing when dealing in. So we're adding 20. That makes 200. 180 makes 200. Okay? So tan 20 is over here. So this is this idea. It's the exact same idea of having counts. Okay? It's the exact same idea. So the proportions are going to be the same here in x and y as they are in here, the proportions. Now, because it's tan, one's positive and one's negative, and so you get tan. It's the same thing. Okay. What about so the same thing for 260. 270 is here, so 260 is there. Okay, so that's 180, 270. So 260, and in particular, it's looking for cos. It's looking for that value there. Okay. Now for minus 80, what would we have to do? We would have to go to here. Minus 80. So this is the same. That's all it is. It's the same. It's just your count. Looking at x. So that's the association kicking in. Okay. Now the other thing about that is, why is it the same? Because there's a minus there. Okay, minus cos 260 is in fact minus. Cos 260 is in fact plus, but you've got the minus out the front to make it the same. So numerically it's the same. So there's a little bit of thought there to think about those. Okay? All right. So what I would suggest you do is really focus on our exact values tree. Okay? And really focus on, in each quadrant, what does it look like? Okay, really focus on each of the quadrants. This one here, it's the same, y equals x. Okay. Or root 2 over 2. Remember, we normalised it. The angle really focus on that. Okay. Let's get a green one going. And theta is equal to 60 degrees, which is pi on 3. Okay, really get used to that. Alright, that's our quadrant 1, as it were. Okay, what's quadrant 2? And 3. And 4. And that's only positive angles. Okay, that's only positive angles. So just focus in on that. Make sure that we get that sorted out. What about quadrant 2? We have negative 1 pi degrees. How many counts around is that? What's that length? Now it's minus root 3 on 2. Positive a half. Okay? That's all it is. 1, 30, 60, 90, 2, 3, 4, 5. So theta is 5 lots of pi on 6. Okay? What about this guy here? going halfway. Same thing. Theta is 45 degrees, which is pi on 4. Not quite, because we've got to do the count. Okay, we've got to do the count. 45 degrees, 90 degrees, 1, 2, 3. 3 lots of 45 is 135, okay, which is 3 lots of 45 or pi on 4. Okay, so we're just getting used to that whole thing. The sides haven't changed. This is now a negative 1 on root 2. This is still a positive 1 on root 2. Just like it was there. They're both positive. Okay? X and Y changing. So that's all we're asking you to do. Just come to terms with that. Okay? This one here's the big one, isn't it? So it's theta is just 2 counts, 60, 120, which is pi, 2 lots of pi on 3. So we've got to get used to recognising that. It's minus a half now, but it's still positive root 3 on 2. Okay? Just go around and label them. That's all we're doing. Okay? And doing our counts. So I'll put them in quadrant 3. So put our 60 degree all the way around to there. Put our 60 degree in here. All the way around. Round you go. Okay. So theta equals 1, 2, 3, 4, 5 lots of pi on 3. 1, 2, 3, 4 lots of pi on 3. Okay. Now going for our, and then you've got your corresponding sizes. Our middle ones, okay. Same size. The theta now is 1, 2, 1, 2, 3, 4, 5 lots. Pi on 4. Over here, same size, same angle, 45, 2, 3, 4, 5, 6, 7 lots. Pi on 3. Okay? So just getting used to those. And this one here, 30, 60, 90. There, it's got some extras in it, hasn't it? 1, 2, 3, 4, 5, 6, 7 lots of pi on 6. This one here, 30, 60, 90. It's going to be a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 lots of pi on 6 to get you to there. Okay? So these are, and then look at the proportions and the size. Okay, and you can work out plus or minus with your pi's, and you can do it that way as well. Okay, now the other thing that I haven't done here is the negatives. We can repeat all of that for negatives. For negative thetas. Whoops. Minus pi on 6. Minus pi on 4. And so on and so forth. So I really encourage you to think about the negatives as well. Okay? It's quite important that you work your way through that. All right. So I think I was close to saying that we'd get to next week. Okay, so I think I said we'd do that next week. So that's the one we'll do next week. So I'll press the video and pause and pull that together for you, and we'll start there next week. Okay, I'll just annotate that the same as next week.